Day 21. So let's begin with this. Are these two lines parallel?
Yes.
Theoretically, yes.
I mean, like, they're not gonna be like perfectly parallel because of the.
So yes, there's definitely a physical element of I drew them by hand. They're not truly parallel. But are they being represented as parallel? Do I act as though they're parallel?
Yes. No.
I heard yes and I heard no. Why do you say no?
There's nothing that represents them, that says them to being parallel. There's no arrows on the lines. There's nothing. Just
Correct.
lines.
Good. So these could be parallel. They could not be parallel. And there's a difference if that's the case. What if I say that this is 100 degrees and this is 100 degrees? You think they're parallel now? Well, before we get there, let's try this. What if I tell you this is 100 and this is 108? Now you're sure they're not parallel? Why? Well, we know that if parallel corresponding with transversal, then what? Then these are congruent. You guys agree? What's my P? And really, these are context, aren't they? P is parallel. If the lines are parallel, then the corresponding angles formed by the transversal are congruent. So can we agree that parallel to congruent, this is our conditional, and that the corresponding and transversal are really context cues? And if you're saying that these are not parallel, then you're saying because these are not congruent, these lines are not parallel. If this is our conditional, if P then Q, what's this one where we say if not congruent, then not parallel? Is it the inverse, the converse, the contrapositive? Come on, guys, you just took a test on this. You're trading places and negating. This is contrapositive. If we go back to the hamburger analogy, is the contrapositive reliable bun or mystery meat? The contrapositive? It's bun. It's down here. So if we know if P then Q, can't we rely on this also being true? These are reliable bun. Therefore, if parallel, then the angles are congruent. If the angles are not congruent, then the lines can't be parallel, because if they were parallel, what would have these angles been? Congruent, and they're not. So you're right. We can validate that these two lines, as are written here, are not parallel because of that. Are these parallel? Why? So if my rule is if parallel, then congruent, and you're saying, okay, well, these are congruent, therefore the lines must be parallel. What structure is that? That's the converse. Is that mystery meat and unreliable, or is that reliable bun? That's mystery meat. I cannot make this claim from this theorem or postulate. But it turns out, don't you think this must be true? Forget about our rule for a second. Let's pretend that this angle is not 100. Can we agree that if it's 99, these lines are not parallel? If it's 98, these lines are not parallel. If it's 96, they're not parallel. If they're 101, if it's 102, if it's 106, every single angle measure other than 100, it's not parallel. Agreed? And if we think about every single measure that it could possibly be, we say that every single measure other than 100, it's not parallel, right? Isn't there some place where it is parallel? And if every place these are not congruent, it's not parallel, and there is some place where it is parallel, doesn't that mean that the only place it's parallel is where this angle is 100 degrees?
Yeah.
Yes. So therefore, I'm going to ask that we accept this as our next postulate. This postulate says, if I've got transversal over two lines, forming corresponding angles that are congruent, then the lines must be parallel. Remember, we only accept postulates if we believe it without proof and know that it must be true. Can we accept this? Any challenges to it? Okay, great. So that means that in addition to our theorems we've already done, saying if parallel, then corresponding congruent, if parallel, then AIA congruent, if parallel, then AEA congruent, if parallel, then same side interior supplementary, if parallel, then same side exterior supplementary, we're now adding a whole new group, beginning with if correspondings are congruent, then the lines are parallel. That's our postulate. And what we're going to then be able to do is say, let's see. So if I'm saying that this is 100 and this is 100, forcing these to be parallel, what if I actually don't know this angle, but I know this one? Same thing, because even if I'm given alternate exteriors, I know because these are vertical angles, this is 100. And if these two are congruent, these lines are parallel. What if I know this is 100 instead of this one? Even if I'm given alternate interiors, I know these are vertical, therefore this is also 100. That gives me corresponding angles congruent, which I'm saying is my postulate. So now these lines are parallel. This is what we're going to work with today. In addition to accepting this postulate, we are going to prove that if the AIAs are congruent, the lines are parallel. If the AEAs are congruent, the lines are parallel. If the same side interiors are what? Good. Supplementary, not congruent. And the same side exteriors have to be supplementary, then parallel. These five theorems, four theorems and a postulate actually, we're going to prove the four, accept the postulate, use them today. In your packet, let's start with this where we're saying, let's demonstrate what the corresponding angles converse would say here. What's a pair of angles that are corresponding here? 1 and 5, sounds good. So what we're saying is if angle 1 is congruent to angle 5, then what? Good. In this case, the lines are called L and M. L is parallel to M. What would be a pair of alternate interior angles such that the converse would apply?
4 and 6.
4 and 6, sounds good. If 4 is congruent to 6, then what? L is parallel to M. What do all 5 of these things have in common? They're all going to end with, that means the lines are parallel. Notice here that this particular worksheet describes these as consecutive interior angles. We don't call them consecutive interior angles. What do we call them?
Same side.
Yes, I call them same side. What they mean by consecutive is that they're one after another inside here, which I don't know how that works for exterior. I don't see them being consecutive, so I never use consecutive. I use same side. You'll hear both descriptions over time. I also like same side because it reminds us they're supplementary. What would we expect to see for the same side interior angles converse? In what condition are the lines parallel? Which ones? Yes, but which ones? We have to pick angles that satisfy this, same side interior angles. Good. So if we said angle 3 and angle 6 are supplementary, then we could say the lines must be parallel. So the second step here is for us to do some examples. If you look at number 1, are these two lines, L and M, parallel?
No, yeah.
Step 1, I see some angles marked here. What's the named pair relationship of these angles? Alternate exterior angles. Are they congruent? Are they supposed to be congruent? Yes. If those are congruent, we can then say that L is parallel to M. These are congruent, therefore L is parallel to M. What about number 3? Are those lines parallel? Okay. Good. These are same side exterior. We need them to be what? Congruent or supplementary? Supplementary. Are these two angles supplementary? 48 and 132 is 180. That's supplementary. Therefore, L is parallel to M. What about number 4? Okay, what kind of angles are these? Vertical angles. Are vertical angles supposed to be congruent or linear pair? Or supplementary? They're supposed to be congruent. Does that mean the lines are parallel if vertical angles are congruent? No. This has nothing to do with this other line. This other line could be in any direction. It has nothing to do with these. It's true that they're vertical, and it makes sense that they're congruent, but we cannot make a conclusion, no conclusion about the lines being parallel with that information. Questions on this page? Does this feel like a lot of information? It does, doesn't it? Are we going to do any of those? Yeah, you're doing all these. It just means they're congruent. Question, Tessa? Yeah, it does. This means that those two angles are congruent. What type of angles are they? So you'd say since corresponding are congruent, is that enough to give us our parallel lines? It is. So we'd say L is parallel to M. Those markings being congruent. Yeah.
Number 6, they aren't supplementary.
Correct.
What would you write for that?
So you'd say not parallel.
So it would be not like
You'd say
not.
if same side interior is not supplementary, then not parallel. It's not a no conclusion. In fact, it's enough to say they're not parallel. Sorry.
All right.
Okay. Please settle down. Let's get through this. Page 2. Now we're given a graphic that's got the potential for two sets of parallel lines. Could be A and B, could be C and D. I'm going to give a little, guys, please stop talking. I got a few more minutes of instruction, then I'll leave you to the rest of this. I'm going to highlight these things some different colors here. It tells us that 2 and 4 are congruent. Is that enough information for us to say, oh, that means these lines are parallel? Okay, so the first question is, what is the named pair relationship with 2 and 4? And I ask you to look at it this way. The 2 angle is formed by this orange line and this green line. Agreed? It's formed between those two colors. This 4 is formed by the orange line and the yellow line. Agreed? Since they're both using the orange line would have to be their transversal. And the other two lines would have to be the parallel lines. Given that context, what's the names pair relationship of these? Corresponding. The corresponding angles postulate and the corresponding angles converse postulate says these two have to be what? Congruent or supplementary? Congruent. They're given to us as congruent. Therefore, can we claim the lines are parallel? Yes, we can. And it'll be the one that's not shared, not the transversal. So it would be the green and yellow, C and D. So we're going to claim that C is parallel to D. And the reason is because if corresponding are congruent, then parallel. Let's jump down to G, please. 4 and 15. Is that enough to say that one of these pairs is congruent? Or excuse me, it's parallel.
Yes.
Okay. If so, why? Good. You're recognizing that 4 and 15 share the yellow one. So that's their transversal. And the orange and the black are the other ones that form those angles. So those would be parallel. In that context, these are alternate exterior angles. And if alternate exterior angles are congruent, which is what we're told, then the lines must be parallel. So which parallel lines would we say here? Good. A and B, the ones that aren't the transversal and yet make up those lines. What about K? 6 and 11. What do you think? Which colors make up angle 6? Orange and green. Which colors make up angle 11? Yellow and black. Is there one color that forms both of these angles? Therefore, there's no transversal. Do any of my rules apply then? No, I have to have a transversal. So this is no conclusion. Is it possible that they're congruent because then 6 is the same as 8 and 8 is the same as 11? And thus both sets are parallel? Yeah, that's possible. But it's also possible that we're looking at a scenario more like this, where these opposite angles are congruent and there's no parallel lines going on there. So that's why we said no conclusion. This same idea, I think of coloring it and identifying the transversal as helpful. Take a look in this number 8 section down here, C, 1 and 17. So here's angle 1 and here's angle 17. Step 1, what's the transversal that's shared by both of them? Yep. Step 2, what lines are forming those other than the transversal? Not Q, P and R, right? P with the yellow forms 1 and R with the yellow forms 17. Therefore, those are in corresponding relationship and they're congruent as I expect. So if corresponding congruent, then parallel. And in this case, I'd choose P is parallel to R. Questions? Down here, the transitive property. If P and Q are parallel, going the exact same direction, same slope, and Q is parallel to R, going the same direction, same slope, then what can you say? Good. P must also be parallel to R. Use that idea, please, to figure out which lines are parallel and justify why. Flip to page 3. There is nothing for you to do on this page. This is just all the notes from these 2 sets of chapters. These are all the ones we did last class, where if parallel lines, then they're congruent. By the way, if you're doing flashcards, every one of these lines should be a flashcard you're working on. I strongly urge you to use that. That will help you. If you flip to the next page, I think you'll enjoy these. These are like puzzles. I'm going to do a couple of them with you. Please go down to the second set down here. How big is angle A? 90 degrees? Why? This little square means 90 degrees. And A and B are in what kind of relationship? Linear pair, which makes them supplementary. Good. So if B is 90, which is told to us explicitly, then A has to be 180 minus 90, which is also 90. What about C? First of all, what does this little symbol here mean? Does this tell us a size? It tells us this angle has the same measure as this angle M down here. They have the same markings. Just like this K here has the same measure as J. We don't know what it is. So how do we find C? Is it 100? Are those corresponding angles? They are corresponding angles, but are these 2 lines parallel? No. Therefore, I can't say that the corresponding makes them congruent. That doesn't help me. What about those 2? These 2, yeah, what? They're congruent, good, because they're corresponding, and these lines show to be parallel.
C is 70 degrees.
Nope, C is 55 degrees. Because these are corresponding angles with parallel lines, therefore they're congruent. But I think you just found something interesting, which is exactly where I was going to go next. Please listen to this, because this is a little bit beyond what you've known. What do these marks mean? They're equal. So this triangle, I'm going to turn my paper a little bit. This triangle has these 2 sides the same. Do you remember what that's called? A triangle that has 2 sides the same is isosceles. Good. And soon we'll learn this. Right now, you probably don't know this, but an isosceles triangle has symmetry so that like it folds together in half and it's the same on both sides, which means this angle C that we just found was 55 degrees is the exact same size as this angle W, 55 degrees. And if those both add up to 110, how much is left for this angle T? Because all 3 angles in a triangle add up to how much? 180. So if I say 180 minus 110, I get 70 degrees. Angle T is 70 degrees. So now let's fill those in. W was 55. T was 70. And that should allow you to fill in the rest of this. One more piece of instruction, then I'll just leave you the period to finish this up. Please go to this other side. We're going to prove the converse of the AIA puzzle proof. Just as we did before, we've got a postulate, the corresponding angles converse. If the corresponding angles are congruent, the lines are parallel. And then we've got these proofs that we're about to prove. And we will prove all of these proofs ending with, so the lines are parallel, using this as the reason for the lines being parallel. So for example, we're now going to prove if two lines cut by a transversal so that alternate interior angles are congruent, then the lines are parallel. I'm going to start with 6 and 3. My alternate interior angles are congruent. That's my given. I've also got the transversal. I could have looked at the picture and taken that, but I'll just say it's part of my given. And what I'm trying to prove is that L and M are parallel. So I'll start knowing that my given is first. And what's my first reason? Yep, this was given, so I write given here. There's a second half to my given here. It says T is the transversal. So what do I write for the second reason here? Excuse me, for statement, transversal, good. And that's either given, or you could look at the picture and say, well, it's crossing over, and that's the definition of a transversal, so I can call it that. And now let's just take a pause for a second here. What's our goal? Where are we trying to get to? L is parallel to M. And as I've said, we're going to be using our converse corresponding postulate to do this. So if two lines cut by a transversal such that a certain type of angles are congruent, then the lines are blank. What's our conclusion here that we're trying to get? We're justifying this step. So our reason here should be, well, if this is true, then lines are parallel. So that's our conclusion. So that should be what follows the then in our theorem we're stating here, or postulate. And since we only have the postulate so far, we've only accepted that, we're going to say, if what kind of angles are congruent, then the lines are parallel. We've accepted the postulate, right? We've said if corresponding angles are congruent, they're parallel. We've accepted this. It's a postulate. Now we're going about proving these. Can we use this postulate to prove these? Yes, we have to. So here, when I want to figure out how I get from all this information to saying the lines are parallel, it has to be that my corresponding angles are congruent, therefore the lines are parallel. And this sets up the rest of the proof. I have to have the transversal. Have I stated that there's a transversal? Yes, I stated that as my given in line 2. Have I found corresponding angles that are congruent? Look at the picture. Which angles are corresponding? Which ones are corresponding? 2 and 6. Good. So I need to say that 2 and 6, or in this case, 6 and 2, are corresponding angles. Can we agree that they are? When I look at this picture, aren't those in a corresponding relationship? So I'll call them that because the what of corresponding angles? Yep, definition. That's what they're called because that's what they're called. Now, the only way I could use this theorem is if I end up saying transversal corresponding angles congruent. I need to get congruent. I need to get that 6 and 2 are congruent. I don't know how yet. I've got 6 and 3 from given. So who do I need to get in the game? 2. Well, do I know anything about 2 and 3? 3 and 2 are what kind of angles? Vertical angles. Why do I get to call them that? When you look at this picture, how do you know that those are vertical angles? Because that's the definition, right? So I call them that because that's the definition. Now that I've said they're vertical angles, I can say if they're vertical angles, then they're congruent. And my conclusion should match what I'm claiming right here. It does. Angle 3 is congruent to angle 2. Nice. So I had 6 in game and I had 3. Now I've got 3 and 2. Can I put those things together? Ooh, so close. Substitution doesn't work in the world of congruence. Transitive, good. And am I set up correctly? 6 to 3, 3 to 2, therefore 6 to 2. Yes, I'm all set. I don't need to use symmetric to fix it. This is the transitive property of congruence. I filled everything in. My logic is sound. QED. Drop the mic. Five. I think I actually can write that proof myself. 3, I understand that we're only responsible for filling in a scaffolded proof. I can do a scaffolded proof of that. 1, I don't think I could fill in a scaffolded proof. I was able to write in what you said, but the logic escapes me. Good. Just about all 3's enough. Nice to see. Okay, you have the rest of the period to finish up this packet and submit this as homework 21. It's got a couple more proofs, same style, as well as this little puzzle activity and whatever other things we left blank. You've got the period.